about the TCS34725 RGB color sensor from Adafruit. Here's a picture of how the wiring works. There are four requirements for to hook up this sensor, and in order to make it work, first we need to hook up the power from the 3.3 watt to the VIM, which is like the power, and then the ground goes to ground. The SCL pin goes to the analog 4 pin on the Arduino. In the video that I use, on the video I used a third-party Arduino, which contains Bluetooth functions integrated on the board itself, so it makes the board capable to do Bluetooth connection. Also, you need to hook up the analog 5 to the SDA pin on this color sensor. So what does the sensor is, this white LED will send out the light, and then the light will reflect on the object that you use, and then this receiver will calibrate the color into a value and send it back to the color Arduino itself. So let's take a look at the Arduino code. On Arduino code, this is like actually sample code. After you install the board, the board from the Adafruit, that you might find the this is not okay. You might find example codes from here. For example, Adafruit says Adafruit TCS34725, and then originally this is color view. This is like the not the one I use, but you can actually use this to check whether the color sensor works or not. The one I use, the one that I been using, it's the hold on, code. Go down to TCS34725, and then there's I think it's this one. Nope, not this one. Okay, must be the last one. Yes, it's the last one. So the last one gives you a little bit more information at the bottom. So it sends out the gain of the entire sensor, and also give you a raw RGB value from the sensor and a clear value. So at the beginning, I was really confused about how those data coming back, because like it says it's a raw RGB, but technically the sensor, I think they calculate the value, how much light exists in this object instead of like actual RGB. So those numbers are actually like a 4-digit or 5-digit number, so you can't really see what like out there basically. And then after that, in this application, I actually hooked up to processing. On the left side, there's a processing code that I wrote myself. First, you just need to hook the board, connect to the port, open up the serial port, and then receiving data from the serial. And make sure this is, you have to develop, if you're on a Mac, then you make sure you have this one on there as well. And then I have all this audio file that I created in Logic Pro, and then into a small wave sound file, and then putting those files into the folder called files in the processing code. Because and then also have the background of like what, so they can see what exactly it is. And then I also created RGB value down here. So what it does is basically catching. So hold on. So and here it reads the data in, and then it split tokens. Each token, which is the I used the comma to actually split the data. So on the right side, I put a comma here. So eventually, what it does is like it sends out R value and then comma, G value and then comma, B value, comma, and the last one C was just clear value. And then on this side, on the left side, which is reading the data as a string, and then you split them into an array by when it recognizes there's a comma. So on red, so first value will be red, and then second one will be green, last one will be blue, and the last one will be C. So the weird part that that the sensor was using, it's basically instead of like the raw RGB value, you have to convert it back. I've actually converted it back into processing, which is R is equal to R value divided by C, which is a clear value, and then times 256. Then it will be equal to the actual R value you have. So after you figure this out, you will get the actual RGB value instead of like the some of the data here. You can see it will be valued with a little bit of decimals, and then those values are actually RGB, so maximum will be 255. And then after that, you can map it to whatever you want. So for example, on here, let's say the first file, it's a DAW on a piano. So do, re, mi, fa. So DAW first file, then it says if R is larger than this, and the green is smaller than this number, and the blue is smaller than this number, then you play this file. And then there's re, mi, fa, sol, la, si, do, and then everything will be fine eventually. So if you all the codes and the Arduino codes and processing code will be uploaded to the GitHub, so you can find out all the information, including the wiring image. Hope you guys like this tutorial, and thank you very much.